getting closer and closer. Think about it, if g's location was at y equals 5, then because it's an open circle, you could use limits and think about, well, I could be at 4.9, or 4.99, or 4.999, right? I could just keep adding and getting closer and closer. So technically speaking, there is no absolute maximum here, and g would just be considered to be neither. It doesn't have a window around it, so you can't call it a relative maximum. It would only be neither. And that's because of your open endpoint. The last thing on this first side is what's called the extreme value theorem, and it's what we would call an existence theorem. It just says that if a function is continuous and on a closed interval, so you have to have a closed interval here, it can't look like our point G on the last example, then you are guaranteed that f will have both an absolute maximum and an absolute minimum value on the interval. It may be that you have what you would sort of consider to be, right? I could have asked you in pre-calc, and many of you would have labeled the absolute minimum value. It could be, though, this picture, where it's just occurring at the endpoints. But as long as you have a closed interval, the extreme value theorem guarantees that you would have an absolute maximum and an absolute minimum value on your interval. I'm going to pause and start a second video just for timing, and that'll pick up on page 2.